Hello students! So this video here is about solving quadratic equations by completing the square. Now some of you might be wondering, okay, what exactly is completing the square? And what do you mean when you say completing the square? Well, I'm glad you asked. Completing the square refers to rewriting a quadratic expression or a quadratic equation as a perfect square binomial. And so you may actually have to rewrite it as a perfect square trinomial first, and then but again, the end result is as far as completing the square is concerned, the end result is getting it in a form so that it's written as a perfect square binomial. So for those who can't quite remember what a perfect square binomial is, it looks like this or like this, and you've actually seen a perfect square binomial before. When we were talking about factoring perfect square trinomials, you saw perfect square binomials, because the way to factor a perfect square trinomial is, again, by factoring it into a perfect square. The way to factor a perfect square trinomial is by factoring it into a perfect square binomial. So again, you have seen perfect square binomials before. But again, when we talk about completing the square, we're talking about rewriting a quadratic expression so that it is written as a perfect square binomial. Alright, so we're going to go ahead on and jump directly into an example of us solving quadratic equations by completing the square, because the easiest and simplest way for me to explain this to you is by actually walking you through each step as we work out a problem. So that's what we're going to do. We're going to talk about each step of it before we start completing the square and after we start completing the square as well. Alright, so let's look at this example here. First off, if we even want to solve a quadratic equation by completing the square, there's a few things that we gotta take care of before we start completing the square. You need to identify what your a value is, and remember that that a value, we're talking about a quadratic equation or quadratic expression, the a value from the standard form, ax squared plus bx plus c. We need to make sure we identify what that a value is, and if that a value is not 1, then we need to go ahead on and divide every single term by that a value. So again, if that a value or if that leading coefficient is not 1, then you need to go ahead on and divide every term, every separate term. And remember, terms are parts that are separated by a plus or minus sign. Okay, you need to divide every single term in that equation by that a value if the a value is not 1. So if you can't tell what the a value is in this form, and some people can, some people can't. It depends on who it is that's looking. Okay, Mr. Starkey, you're gonna have to remind me. How do I determine what the a value is again? Okay, I don't have a problem in doing that. All right, so we can rewrite it in standard form, or some people might be able to tell what the a value is with it looking like this. But again, in standard form, if all three terms are on the same side of the equation, it may be a little easier for some folks to tell what we mean by the a value of this. So let's see, if we get all terms on the same side, it may be easier for some people to tell what that a value is. So let's see, if we add 3x squared to both sides, that's 3x squared plus 12x minus 9. Okay, so equals 0. So as of right now, we've got this thing written in standard form. That's not really required. us writing it in standard form is not really required, but some people may need to see it in this standard type of form in order to really be sure that you know what the a value is. And not everybody may need to have it written in standard form, in this form, ax squared plus bx plus c. But again, this is standard form, and in this form, if we go ahead on and identify the a value, we can see here that the a value is 3. Of course, like I said, folks, you could have left it in its original form, and in its original form, that a value or leading coefficient would have been a would have been -3 if you had left the equation in its original form. Your a value would have been -3. Yeah. So again, folks, after you've identified what that value of a is, if the value for a is not 1, then you should divide every term. I mean every term. You must divide every term on both sides of the equation by that value of a. Divide every term on both sides of the equation by that value of a. So let's take a look at what that looks like when we actually do that. And so again, I'm just going to rewrite this equation, 3x squared plus 12x plus minus 9. Again, as I had mentioned before, folks, it was not a requirement for you to write this equation in standard form. But again, for some folks, it may have been easier for you to identify what the a value was, or what that leading coefficient was when it was in standard form. Again, if you had left it in its original form, if you had left it where the -3x squared was on the right side, then your a value in that case would have been -3. Okay, so regardless of which form you got it in, if you've correctly identified your a value, and if that a value is not 1, then you should divide every term on both sides of the equation by the value of a. So again, for those who didn't rewrite this equation in standard form like I did on this video here, then you're going to be dividing every term by -3. But again, based on what I've done here, we've identified our a value as 3. And so I'm going to divide every term by that. So we divide, sloppy. All right, let's try that again. So we divide that by 3, we divide this by 3, we divide this by 3, and we divide this by 3. Every term, this term split by a plus or minus sign, this term split by a plus or minus sign, and this term split by a plus or minus sign on both sides of the equation. Yes, 0 is the only term on the right side of the equation. However, it's still a term. So you divide every term on both sides of the equation by that value of a that you identified. Okay? And so let's see here. When we do that, of course, 3 over 3 simplifies to just 1, or in other words, just x squared. 12 divided by 3 is 4. And so here that's going to be 4x. -9 divided by 3 gives you -3. All right, and then 0 divided by 3 is again 0. Folks, remember that it is possible to take 0 and divide it by a number. It only presents a problem if 0 was at the bottom here. If we had some number and then that number was divided by 0, that would be when it would present a problem. But again, as it is right here, this fraction 0 divided by 3 does not present a problem. 0 divided by any number is going to be 0. All right. Okay, so now that we've got it where our a value is 1, and so now that we've got it like that, what we want to do is we want to sort of separate our terms with variables from our constant terms. In other words, we want to isolate our terms with variables on one side of the equation and we want to get the constant terms on the other side of the equation. So let's isolate those variables, those terms with variables, and let's get the constant terms on the other side of the equation. Okay, so again, folks, let's see what that looks like after or during the process where we're isolating those terms with variables. So you can see here that we've got two terms with variables, that x squared and that 4x there. And so what we need to do is we need to go ahead and get those two terms by themselves. And so the only thing that's keeping those two terms from being completely by themselves is that -3 there. So let's go ahead on and let's move that constant term, that -3, let's move that -3 to the other side of the equation. So let's use an inverse operation, right? So the inverse operation we need to use here, and you should know, is us adding 3 to both sides. Okay, so when we add 3 to both sides, that's going to cancel that out, and then we're going to be left with x squared plus 4x equals 3. All right, so at this moment now we do have it where our variables, or our terms with variables, are isolated on one side of the equation, and that constant term 3 is now on the other side of the equation. All right, so and remember, folks, this was all stuff that we needed to do even before completing the square. So now that we've got our equation arranged like this, and now that our equation is actually arranged in this correct way, where our again where the a value is 1, and where the variables, or the terms with variables, are on one side of the equation isolated, and the constants are on the other side. So again, now that our equation is actually arranged like this, now we can start the process of completing the square. All right, so let's look at how we actually complete the square. How do we do that? Well, I'm glad you asked, folks. All right, so now that we have actually taken our original equation and we've divided by that value of a if it was not 1, and we've gotten our terms arranged, or the equation arranged so that the terms with variables are isolated on one side, and that the constants are on the other side of the equation. Guys, when we divided by that value of a, we actually created a new equation. Now, mind you guys, this new equation it's still equivalent to our original equation, but again, technically it is a new equation. And so now that we've got this new equation where the a value is now 1, so the a value was not the only thing that changed from the original equation now to this new equation. And so I'm pointing that out because I need for you to be looking at this new equation and not at the original equation when I say what I'm about to say next. Okay, so you need to be looking at this new equation that has the a value of 1. And in this particular example, this new equation is x squared plus 4x equals 3. Okay, so when we are completing the square, you look at this new equation and you need to calculate. The first thing that you need to do with completing the square is you need to calculate b divided by 2 and then square that quantity. I'm going to say that again. So first off, with this new equation, the equation where the a value is 1, first off, if you have not already identified this new b value, divide it by 2, and then take that quantity and square it. Calculate b divided by 2 squared. Okay, so let's look at exactly how that's going to look. Alright, so again, we've got this new equation here, and let's identify what b is. So again, we've got it in the form, and right now it's in the form ax squared plus bx, and it is equal to, technically is equal to negative c. But anyway, we can identify what the b is here. Again, I'm just going to write out this particular part of it right now. This part of it is the ax squared plus bx. Okay. And again, in that particular form there, b is 4. All right, so since b is 4, and what we need to do is we need to go ahead on and calculate b divided by 2. That quantity b divided by 2 squared. So the way we do that, the way we calculate that quantity is, first we take our b value, which we just identified as 4, and we divide it by 2. So first off, b divided by 2, that's 4 divided by 2, which is, okay, what's 4 divided by 2? 2. So that's the first part of it. Take b, take 4, and divide it by 2. Next, you want to take that quantity, that result that you just now got from taking b and dividing it by 2. Okay, we just got the result of 2 here. So we want to take that quantity and we want to square it. So we're taking that quantity of b divided by 2 and we're squaring it. So now we're going to take that b divided by 2 and we're going to square it. That is us taking 2 and squaring it. 2 squared. 2 squared is 4. Whew. That might look a little bit sloppier than what I intended, but it's okay. It is all right. All right, so again, 2 squared is 4. All right, so what we do with that is now we want to actually add, that number. We want to add that result that we got from calculating the b divided by 2 squared, quantity squared. We want to take that number and we want to add it to both sides of our new equation. We want to add it to both sides of this new equation. All right, so let's look at what that looks like when we take that value that we just got, that value that was the result from that previous step that we just did. Let's see what it looks like when we take that value and we add that number to both sides of the equations. All right, so I'm just going to bring down again this new equation that we had, or at least parts of it. The whole thing really, but again, so that was x squared plus 4x, and again we said that we are going to add that value that we just now got to both sides of the equation. So I'm putting a little plus, and again you feel in your imagination here. We got to add that value that we just now got, okay, to both sides of the equation. Right, and again, so remember that value that we're adding to both sides of the equations is the result that we just now got from calculating that b divided by 2 squared. And remember, in this particular case, that result that we just now got was 4 when we when we did that b divided by 2 and took that quantity and squared it. All right. So we're going to add 4 to both sides of the equation. So let's go ahead on and rewrite this. And again, we're adding that quantity, that number 4, to both sides of the equal sign. X squared plus 4x plus 4 equals 4. Oh, wait a minute. Hold on. That was... I'm sorry, I wrote the wrong number here. I'm glad I saw that here. Good. That number from our new equation was a 3 there. Again, that new equation was x squared plus 4x, which is what we had there, and it was equal to 3. Alright, so that is equals 3, okay. And again, what we're adding to both sides is this number 4. Plus 4. Alright, so now that we've added that number to both sides, let's see if we can combine like terms. In this case, and guys, remember, combining like terms only works when the terms are on the same side of the equal sign. So the 3 terms that are on the left side of the equal sign, you can't combine those because they're not like terms. But these 2 terms on the right side of the equal sign, we can combine. Now, again, you don't want to try to combine anything that is not on the same side of the equation. But again, these 2, 3, and 4 on the right side of the equal sign, we can. And so 3 plus 4 on the right side of the equal sign is 7. And then we just rewrite this, x squared plus 4x plus 4. Alright, so now we've got yet another new equation that got formed by us adding that quantity to both sides, by us adding that number to both sides. We've got a new equation again. So the next step that we need to take is we need to rewrite our quadratic trinomial. We need to rewrite that quadratic trinomial, and I'm talking about the expression that is on the left side of the equation, or whichever side you've got a quadratic trinomial on. If you happen to be solving an equation and you got into this step and your quadratic trinomial is on the right side, use your imagination. But anyway, we need to rewrite our quadratic trinomial as a perfect square binomial. And there's a specific way that we can do that. Now, of course, I know that a lot of us remember how to factor a perfect square trinomial, but guys, there will be some cases where it's going to be easier to just use this formula that I'm about to tell you about to rewrite our perfect square trinomial as a perfect square binomial. And again, it will be easier in some cases, especially if you've got any fractions involved. And yes, there will be some times where we will have fractions. But anyway, so guys, first of all, please realize that when we added this number to both sides of the equation, what we did was we created a perfect square trinomial. And so, like I said, you may or may not recognize it as that, but that's what we created. We created a perfect square trinomial when we added, and in this particular example, when we added 4 to both sides of the equation. So this next step is where we want to rewrite that perfect square trinomial that we just now created, that we just formed. We want to write that perfect square trinomial as a perfect square binomial. And we want to write it in this particular form. Again, that form that I'm talking about is x plus b in parentheses, and that quantity in parentheses squared. Now, some people, if you don't pay attention to what I'm saying right now, are going to make this mistake. You are going to make the mistake of writing 4 where you see the b, so where you see here b divided by 2 in this form that I'm telling you about, some people are going to make the mistake of writing 4. You're going to write x plus 4 inside the parentheses and then the square on the outside of the parentheses. You're going to make that mistake if you're not listening to what I'm saying right now. So guys, remember that quantity that we found, that we calculated before, that was not b, it was not only just b divided by 2. That quantity that we calculated was where we took the b divided by 2 and we actually squared that number. Here, I am not asking you to square b divided by 2. I'm asking you to write b divided by 2 here. So when you write it, I'm asking you to write x plus, and I'm asking you to actually write the value for b divided by 2. Remember, b was 4, and 4 divided by 2 gave us 2. So what I'm asking you to write here is x plus 2 for this particular example. Please do not write 4. I'm not asking you to square b divided by 2. I just want you to write the value of b divided by 2 here. Again, I've seen so many students make that mistake. That's why you hear my voice so elevated and me emphasizing this. Okay, so let's write this out. So again, we want to take this perfect square trinomial here, and we want to write it in this form. X plus b divided by 2, and this quantity, the x plus b divided by 2 squared. And we want to write it in this form as a perfect square binomial. So again, as I had just emphasized, the number here that we are putting is b divided by 2. b was 4, and 4 divided by 2 was 2. So again, what we're putting here is x plus 2 squared. So again, we are writing x plus 2 squared. We're rewriting this perfect square trinomial as that. But again, guys, remember that this is an equation, and that equation, the other side of that equation, was still equal to 7. And we're just replacing or rewriting this perfect square trinomial here. But it's still an equation, and this side of the equation is still equal to 7. All right, so now that we have written that perfect square trinomial, or we've rewritten that perfect square trinomial as a perfect square binomial, and we can see that here, we've got a binomial and it's squared. It's written in that form. Okay, so now that it is in this particular form, the only thing left for us to do, because at this moment now we've actually completed the square. So we completed the square, but now what we need to do is we need to solve this equation. So the only thing left for us to do now is for us to solve this equation. And we are going to solve this equation by using square roots. Guys, the form that this equation is in should look familiar to you, because we've done a whole lesson on solving quadratic equations by using square roots. So you should know how to solve this equation using square roots. It's already in the perfect form for you to use square roots. You don't even have to even isolate the part of this equation that is being squared. You don't have to isolate that, because it's already isolated. If you've done every step that I've already told you to do, then you've already got the part of this equation that's being squared isolated, and all you've got to do is solve it by using square roots. Alright, so let's finish solving this again by taking or using square roots. So again, this is already in the perfect form for us to go ahead on and just continue solving it. We don't even have to worry about isolating this, the part that's being squared, because if it's written as a perfect square binomial and we followed all of the steps before this, it's perfect, is right for the picking, as they say. And all we got to do is use square roots on both sides and do just like we were doing when we did that lesson. Alright, so remember what happens when we take the square root of something that is being squared. Remember that is going to cancel out the radical, or that square root there is going to cancel out with this square, and we're going to be left with just that radicand, x plus 2. And remember that once that cancels out the square root and the square, we no longer need the parentheses there. So this is x plus 2 equals, who remembers what we need to put here? Who remembers what we need to put here besides the square root of 7? Who remembers how many solutions we actually have here? Exactly. I hope that everybody remembers. Well, I know nobody actually said anything, in here, but still, hopefully everybody remembers that when we're solving by taking or using square roots, that we've got two answers. That's the same reason why when we're doing the quadratic formula has that negative b plus or minus the square root of b squared minus 4ac all over 2a, right? That's why that plus or minus is there even in the quadratic formula, because again, we're going to have two answers, or at least usually when solving quadratics, there'll be two answers. And again, we talked about when there's not two answers, when we talked about the discriminant from the quadratic formula. The only time that there's not two answers is if the discriminant, or that radicand, is 0, if the number up under the square root is 0. But anyway, we've talked about all that. Won't be the last time you hear it. Alright, so we've got here plus or minus the square root of 7, and now we still need to completely get x by itself. So let's subtract 2 on both sides. Minus 2, minus 2. Okay, so who's going to say the square root of 5 here? You better not. You better not. Remember, you cannot combine this square root of 7 with a minus 2. The only thing that you can combine with the square root of 7 is something else that has the square root of 7. If you had two radicals with the same radicand, with the same number up under the radical, that's the only time you can combine radicals with something. But anyway, we've got to write this out separately. You cannot put that minus 2 up under the radical, and you cannot combine the 7 with the minus 2. So here we've got the negative 2. Again, we've got two ways that we can write this. Remember, we can write the negative 2 in front of it, in front of the plus or minus the square root of that 7, or we can write that negative 2 after we write that plus or minus 7. The choice is up to you as far as which way you want to write this. Again, like I said, we can write the plus or minus square root of 7 first, and then we can put the minus 2 separately, or we can put the minus 2 first, and then put that plus or minus square root of 7. It's up to you as far as which way you write that there. And if it was possible for us to simplify anything further, of course we would need to simplify that further. Again, if it was a square root, if it was the square root of a perfect square, then we simplify that. Or if it was a case where we could simplify or write it in its simplest radical form, we would do that and simplify it that way, writing it in its simplest radical form. Or if this winded up being an imaginary number, we would simplify it by writing it as its imaginary form, in its imaginary form. Remember, there's 3 different ways that it's possible to simplify it if we can simplify it. All right, so that's it for this example here. All right, so again, folks, this concludes, those are your answers there, and this concludes part 1. Again, this video is part 1 here. Stick around for part 2. where we'll be doing more examples. Here we've been quite thorough with explaining to you exactly what we're referring to when we say completing the square. We've shown you what things you need to do before you actually start completing the square, and we've talked about what it is that you need to do after you have completed the square. And again, we've shown specifically what steps you need to take when you're actually completing the square here. So again, I do hope that this video has helped, but again, stick around for part 2, where we'll be doing more examples of completing the square, different types of examples. Yeah, that's it, folks. Part 2 up next.